Assembly modeling in SolidWorks is a critical aspect of the CAD, computer-aided design, process, enabling the creation of complex mechanical systems by combining multiple parts into a single coherent unit. This process involves the integration of various components, considering their spatial relationships and ensuring they work together as intended. Creating an assembly. To create an assembly in SolidWorks, users start by opening a new assembly document. The first step involves inserting the primary part, often referred to as the base component. This part is usually fixed in place to serve as a reference for other components. Subsequent parts are then inserted and positioned relative to the base component. SolidWorks offers various methods for inserting parts, such as dragging them from the Feature Manager design tree or using the Insert Components tool. Mating components. One of the core features of assembly modeling is the use of mates. Mates define the spatial relationships and constraints between parts. Common mates include coincident, parallel, perpendicular, concentric, and tangent. These mates ensure that parts align correctly and move as intended. For instance, a concentric mate ensures that cylindrical parts share the same axis, while a coincident mate aligns surfaces or edges. Advanced mating techniques. For more complex assemblies, advanced mating techniques such as gear mates, cam mates, and path mates are utilized. Gear mates simulate the interaction between gears, ensuring that they rotate correctly relative to each other. Cam mates define the movement of a follower along a cam surface, while path mates constrain a part to follow a specific path, useful for simulating belt and chain mechanisms. Assembly features and tools. SolidWorks also provides various assembly-specific features and tools. The Component Pattern tool allows for the creation of repeated components, reducing the time required for manual insertion. The Exploded View feature helps visualize the assembly process by showing how parts fit together and can be disassembled. Additionally, interference detection tools help identify and resolve conflicts between components, ensuring the assembly operates smoothly without physical interference. Simulation and motion analysis. SolidWorks integrates simulation tools that allow users to perform motion analysis, structural analysis, and thermal analysis on assemblies. These tools provide insights into the performance and behavior of the assembly under various conditions, aiding in the identification and resolution of potential issues before manufacturing. In summary, assembly modeling in SolidWorks is a comprehensive process that involves inserting parts, defining their relationships through mates, utilizing advanced mating techniques, and leveraging assembly-specific features and simulation tools. This ensures the creation of functional and optimized mechanical systems, enhancing the overall design and manufacturing process.